Again,
You're gonna get a
come on, guys. The portion that you see in this green box here is exactly what you saw in your quadratics with intercept form. Now, if you have more than 2 roots, though, you're going to have more than 2 factors. That's all it is, and this should be familiar now. So when we had a quadratic, if you remember, we had 2 roots, and then we would find the third point somewhere to use to solve for a. And we would plug in one of the roots here and one of the roots here. Well, now we don't have quadratics anymore. Now we might have something like a cubic where it comes back around. Well, how do you account for the third root? You put a third factor in. So this is x to the n, where n is the number of roots or the number of factors. So if you had 7 different roots, you would have 7 sets of parentheses here. And then you would still do the same process. You would plug in the given point, so plug in whatever point is given and solve for a. Okay, that's what we're going to start with today. We're going to look simply at intercept. Then the second half of the class, which is not going to be in the other sections. So if you're studying with other people in the other class, they're only doing the intercept form. Because the other one we're going to do, remember you did matrix? Okay, so we're going to use matrix to solve for a, b, c, d, e, or however many coefficients there'll be. So we're going to do 2 things today. Again, intercept form and standard form. Standard form, you'll need to do a matrix for it. Okay, so if you don't have a calculator today, make sure when you get home you practice how to use the matrix again. So looking at this problem, it says, if the zeros of a polynomial function f of x are -3, 2, and 1, and the graph passes through the point -1, 24. Girl, stop. Determine the function, please. So how many roots do I have? 3. So how many factors will I have? 3. So please start right away. Y equals a, and then put your 3 factors. Again, the whole goal is that we are going to determine a. We're going to use that point afterward to determine a, but for now, let's just put the factors in. The -3 as a root. What does that look like as a factor again? Very good. X plus 3. Again, the positive 2. What does that look like? And then the positive 1. Okay, so again, you'll notice standard form, as always, is x minus the root. X minus the root. So if the root is positive, it looks like it's negative here, because you see the minus, because it's x minus the root. But here, when it was x minus -3, remember, this was really x minus -3. The double negative became the positive there. Now, at this point in time, the only thing that's missing is a. So with this problem, it's actually quite simple, because all you got to do is plug in your roots, then plug in the point for y and x, and solve for a. Same exact way we did it with quadratic functions. So for y, we plug in a 24, because we see there's the 24 for y. We see the -1 for x, so we plug that in for x. And we just have to do some arithmetic at this point. Okay, again, you're plugging in a -1 in 3 locations. 1, 2, 3 locations. And then you're plugging in the positive 24 in 1 location. If you switch them up, obviously your answer is not going to be right. Just think about it mathematically. Look at the big difference. You'd have 24s here. These numbers would be huge, okay? So multiplying through here, if we solve for a, what do you guys get? I'll tell you if you're correct here. 2. Very good. Who got that? Is it Jason? Is that a guess, Jason? Yeah. Solving for a, you should get 2. Again, because this turns out to be positive 2. This turns out to be -3 and -2. That gives you a total of 12 if you multiply. Again, multiplying these 3 numbers with this, you get 12. So 12a equals 24, thus a equals 2. Again, please remember, these factors are all multiplied. That's why they're called factors. And if you see this week's SAT video, you'll hear me talk about factors and what they mean, the difference between factors and multiples. Okay, these are factors of each other. That's the term we're using. So they must multiply. So multiplying, you see the 2 negatives become a positive. In total, you have 12 when you multiply. So you're going to get 24 equals a times 12. Dividing by 12 on both sides, a is 2. Okay.
Most of the things that were on the section of the ACT did we learn them?
Depends on which ones. If you want to ask specific ones, we can talk about. For example, last year we learned basic trig, SOHCAHTOA. On the ACT, there are things like trig functions, where you see a trig curve, and we're learning that at the end of this year. You guys can take the ACT again in the fall of next year, and we will learn that this year. Okay?
Second chance?
That topic, trig waves, guys, that topic is not usually taught until after algebra 2. Okay, it's like a separate course sometimes. Some people try and put it together. We're going to have it in there.
They have like tan, negative.
They have tan inverse, all that stuff too, yeah. We got to stay on focus though. We'll talk more about that when it comes to it, okay? Unfortunately, the timing didn't work out for us, so we had it early. Now,
When does the scores come out?
usually within like a month or two. I don't really know the exact
They
date.
said 5 to 8.
So a month or two. Again, people, make sure you don't just stop at A. You're actually finding the function. You're finding the actual function. And I should call this f of x because that's what it said in the problem. Just for consistency. Again, the problem, it did say f of x. So I know it says y equals, and that's the same thing really, but let's just name it by the name in the problem. Okay, again, once you get the a value, please remember, you still have to write the actual solution. You still have to write the actual solution. The a value is not your answer. So this is your function right here. And again, if you wanted to go back and graph this next, you could be able to figure out, well, there's the 3 roots already. I could figure out another point. I could determine the y-intercept by setting x equal to 0 and going through all that process. But we're not graphing. We're just finding the equation. So we're doing like the opposite of what we did last concept. Last concept, you were either given the function and you were told to graph it, or you're given some information and told to graph it. Here now, you're given information and told to find the function. So you're going in the reverse direction, or the converse from geometry. Remember converse? You switch P and Q. That's what we're doing now. We're starting with one thing, and we're finding another thing. So we're doing the reverse order. Okay? So let's take a look. This is what the graph would actually look like, in case you're wondering. There's our root at -3. There's our root at +1. There's a root at +2. Any repeated roots here? Why not? Good. No tangent and no inflection point. Again, these are not tangents here. Please don't confuse this. That kind of looks like it's tangent because it looks like it could hit the axis. But a tangent would have to hit the axis and come back around like that. This is not a tangent. It goes through at 2 points, at the point 1 and at the point 2. Okay, that is not a tangent there. Please be careful. Let's go on to the second example. If a graph g of x has a double root at 2 and -2 and a y-intercept of 32, determine the function that represents it. A double root. A double root.
-2.
Good. So I start with f of x, or y, oh sorry, g of x for this one. G of x equals a. Now I know I'm going to have 4 roots because I have 2 double roots. So start with 4 parentheses. You have a double root at 2 and a double root at -2. I kind of made this too easy for you. But the double root at 2, again, the double root at 2 would indicate you have 2 roots at 2. And the double root at -2, I'll use green to show the difference, would look like this as factors. And I know it doesn't matter in this case because you happen to have negative and positive. So if you switched it up, you would still get the right answer here. Again, if you forgot the negative switch, these would both be positive, these would both be negative, which is the same function still. Okay, that's why I said I made it a little bit too easy. Now, you have the point, or you have the y-intercept 32. So how can we use that fact that the y-intercept is 32 to help us?
Plug in 32.
Yeah, 0.32.
0.32, very good, Andrew. Again, 0.32, that's your point. So please plug in 0 for x. It makes this problem very easy when you plug in a 0 for x. Everything just drops off there. So we're going to have 32 equals a times -2, -2, +2, +2. Notice, I literally just dropped all the x's off because they became 0. When something goes to 0, it just becomes whatever's the result that's left there. So this -2 carries down, this -2 carries down. Okay? And what do you end up getting for a this time?
2.
Looks like 2 again. Yep. See, for some reason, when I wrote my problem down, I used 48, but on here it says 32. If this were 48, it would just change this value, correct? So when you see the notes, you're going to see 48 over here. It would make A3. Okay, it would make A3, because 48 into 16 is 3, or 16 to 48 is 3. So solving this one, yes, you get a equals 2. So your final answer for this is as follows. Now, watch what I'm going to do here, because it makes it a lot easier to write this equation. There's your final function. Everybody see what I was doing?
Yeah.
Because I have 2 of each. I've got a double root here and a double root here. So I could have started by doing it like this in the beginning, but I wanted to show you that it doesn't really matter either way. So you could have started by grouping it like this in the very beginning of the problem. It's the exact same process. Okay? This next one's going to be very tricky. Okay? And you'll notice in your notes, whenever you see an H next to the example, it means we're only doing it in this section. So this one is a very tricky problem here, for example 3.
Do you make separate notes?
Do I write separate notes? No. The difference in the notes is some of the problems I do extra. So if you don't see an H there, or you see an H there, these are only doing it in this class. The other notes like this are separate. Yeah, these are different. That's what you need. So the fill-in notes in the other class is only front and back. You guys have front, back, front, back. It's a lot longer. Okay? So this was the graph for the last one, by the way. Why is there a tangent here?
Just two.
Double root in both spots, right? And again, remember I said mine was 48 instead of 32 I used? There's the y-intercept of 48. So with the one we did, it would be at 32 right here. So it would just change the concavity. Okay, it would still be the same direction generally, but it would be less. There would be less curvature to it. Okay. Next, third example. 2 of the roots of a quartic function, 4th degree, are imaginary, and one of them is given by 2 plus I. 2 of the real roots are given by 2 and 4. The curve also goes to the point 3, 4. Determine the function that represents this curve. We got a lot going on here. Can somebody tell me maybe one step to start with, or some identifying information?
The 4 is what?
One at a time. Juliet. So the 4th, good. So we're going to have how many roots? Good. So 4 factors or 4 roots. So you can start like this, because you know already that's going to be to the 4th. That's a good thing to start with. Very good. Derek? Good. So what can I, from the real roots, what can I write as these factors? And? Good. That's the beginning. Very good. Those are the real portions. What's the issue with this problem, guys? You got imaginary roots. Good. Okay. Now, if one of your imaginary roots is 2 plus I, what's the other imaginary root? 2 minus I, because they come in pairs. Very good. So we've got 2 plus I, 2 minus I. Now, the question goes back to, what does standard form really mean? So look back at the top of the front page. Top of the front page, look at standard form. Remember it was A, quantity x minus x1, quantity x minus x2, dot, 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 x minus xn. All that means is we always subtract the root. So here, we did x minus 2, because 2 is the root. Well, this is one of your roots now. This is another one of your roots now. So you have to literally write that. So x minus in both spots. But now you're not just doing x minus 2 or x minus 4. You're doing x minus the quantity 2 plus I. So please put 2 plus I here. And then this one will be x minus 2 minus I. Okay, that's where it gets tricky. Again, right here is where it's tough. But it's the exact same thing we're doing. It's always x minus the root. X minus the root. And that's why these were minus signs, because you're minusing off the root. Well, this is the root, 2 plus I. This is the root, 2 minus I. Why do we put the minus? It all goes back to standard form. Okay? Where every time here, x1, x2, all the way to xn, however many roots there are, it can be 10 or 20, is always minus. It's always subtraction. Okay, again, because of the fact that the root and the factor differ by that negative sign. Remember, if the root is 7, the factor is x minus 7. If the root is negative 3, the factor is x plus 3. Now, can I get a suggestion here? This is where it gets tough. I want to see who can think about this for a little while. What could I do next? I only see multiplication as an operation right now. I mean, I could rewrite this if that's what you're saying, Juliet. I could write this as x minus 2 minus I and x minus 2 plus I if I distribute the negative.
Oh, wait, can you, wait.
Again, what Juliet said was actually show the minus here. So if you distribute that negative to both of these, they both become negative. Distributing this negative, you get a negative, and then you get a negative negative, which gives you the positive. So that's the first thing you could do. John? Well, I mean, sure, we can do that, but again, what's the goal here, John? What's the goal? What are we trying to find? We're trying to find A. We're trying to find A. So to find A, we can plug in for X and Y, but see these I's? They're still going to cause issues. So what can I do with these two?
Get rid of it.
FOIL. But when it's in 3 dimensions, or there's 3 by 3, what do we call it instead?
That's what I said.
Box method. You said, can you distribute
Not
the first
those
two?
two.
Oh, sorry. Yes, those two. So, here's what I want you to do to make this problem easier. Before you plug in the number, before you plug in 3 comma 4 right here, again, before that, multiply these two by each other, and you're going to notice what will happen to the i's. Okay, think back to how we did complex conjugates. Okay, you end up getting I squared at some point. Close. What is I squared? Negative 1. Negative 1. It was the third one on the wheel if you're thinking about that. Or I0, I1, I2, I3. That's the wheel. But I squared is negative 1. And in this problem, when you use box method, you're clearly going to get an I squared here, because you're going to have an I times an I in one of your columns. Let's go through this process now. So, just quickly multiplying. The ones without the i's you should all get right away. Those ones should all be clear as daylight. You're just multiplying x times a number or x times x. Now, when you do the I, here's how you do this. This is when it gets a little bit tricky. Think of this as x times I with a negative. So write negative xi. Again, this is x times I, but the I has a negative. So negative xi. This is just x times I down here. What's going to happen to those two things, guys?
Cancel out.
They're going to cancel. So in a minute, we're going to show that. We could already show it if you would like, that the i's do drop off. You have a negative xi and a positive xi. Next, here you're going to have 2i, and here you're going to have negative 2i. What happens to those? They also cross out. Okay, so all these i's are going to drop off except the I squared, because the I squared becomes negative 1. But we're going to have negative I squared, because we have a positive I times a negative I. So it's just going to be a 1, really. Again, this is negative 1. Again, I squared is negative 1. So this is negative 1, positive 1. Okay, again here, negative 1. Let's combine like terms. I've got the x squared over here. That comes from this portion. I've got negative 2x and negative 2x, which is negative 4x. I've got a plus 4. And then I've got a minus I squared, okay, which is positive 1. So 4 plus 1, simply 5. Very good. So this is the quadratic where those roots came from. So see these two roots, 2 plus I and 2 minus I? If you do the quadratic equation, or if you go to your calculator right now and type in 1, negative 4, and positive 5, look at your roots. They better be 2 plus I and 2 minus I, okay, or else we clearly made a mistake somewhere. So please go ahead and take a look. And what we're going to do is we're going to replace these two factors with this one trinomial. So on the next line, you're going to rewrite the function that we had at the top here. So we're going to rewrite this function, but we're going to replace those two factors with that one trinomial. And now we can solve this problem.
Do we have to still factor?
No, because if you try to factor it, you get these, don't you, Juliet? That's what those are. So if you don't factor, it's okay. You'll see why. This is one of the toughest problems you're going to see. This is a college level pre-calculus problem, okay, for sure. Why are we doing it? So you guys are ready for this stuff. I'm teaching you extra stuff here and there. I've been doing a lot more and more this year. Even like last week, you talked about that word concavity. I never used it last year. I should start using it earlier. That's what I'm trying to do. So you're more prepared. Now, at this point in time, we no longer have an I anywhere. So we can plug in that point. So let's go back up to the problem and see what was that point again. 3, 4. Absolutely right. 3, 4. So plug in your 4 for the y, plug in your 3 for the x. Now notice, wherever you plug in a 3 now, you're going to have a square at some point. Okay? There's not just simple factors anymore. But the math is not any more difficult. It's just arithmetic here. Okay? So again, I'll use red for wherever I plugged in so you can see. Okay? The 3 and 4s are all in red there so you can see the difference. Now, solve, multiply, solve for A. What'd you get in? Negative 2. I got negative 2 here. Negative 2? Again, let's go quickly through in our heads. This is negative 1. This is positive 1. This is negative 1. This is 9 minus 12, which is negative 3. Negative 3 plus 5 is positive 2. So you're going to end up having a positive 2 here. Okay, a positive 2 here, and you have a 4 over here. 4 divided by, I'm sorry, negative 2. 4 divided by negative 2 is still negative 2.
I didn't even do the negative.
Was this g of x or y? Just y?
What?
And notice, your function doesn't have eyes either. You can't have eyes in your function, guys. Okay, you cannot have eyes in your function. So the final answer, you're going to have 2 binomials and a trinomial. Again, 2 binomials and a trinomial. If you want to see what this graph looks like, did I put it on your page? No, I didn't. How many roots should I see on the graph here? 2. Because 2 are what? Remember, 2 are imaginary. Here's the graph. You see the root at 2 and 4, those are the real roots, right? Where's the other 2 roots? It was x to the 4th. Imaginary. Okay, imaginary. And again, we don't know where they are. Why are they both aiming down?
Because it's a 4 positive.
And behavior.
Even.
Even. Negative. Look at A, guys.
How can you be even and odd?
Take a look. The A value turned out to be negative here. So the leading coefficient is negative. Again, because A is negative. And it's even because there are 4 roots. When it's even negative, we know it looks like a parabola opening downward. That was our guess for end behavior. And it does verify that. Okay? Again, it doesn't look exactly like a parabola, and it won't. It's going to have some changes in concavity along the way because it's x to the 4th. All right, let's take a look at this one now. On your page, you might not have seen it as well, but what I did want you to notice was that you have some roots and some things going on there, and you have a y-intercept. It might be more clear up here. Now, what can I write? Again, right away, all we have is a graph here. We want to figure out the function for this one.
There's 3 positive.
Okay, I know one of the roots. Julia, give me one of them.
Actually, no, 2. You know, negative 1 and 2.
Okay, negative 1 and 2, good.
And 2 is like
2 is like 3.
2 is a triple, and negative 1 is a double. Again, please, right away, people. Write this down if you haven't done it or if you didn't say the answer right away. This is inflection, so there are 3 of them, at least 3 of them. We could have more, but we don't know right now, so we can only say 3 for sure. And here we have a tangent. So right away, your function becomes x plus 1 squared, x minus 2 cubed. Does everybody see how I wrote that? We have a double root, focus. We have a double root at negative 1, thus we have 2x plus 1. That's why it's x plus 1 squared. We have a triple root at positive 2. Its factor is x minus 2. When it's a triple root, we have a cube up here. That's the triple root indication, that's the double root indication. Now, what's the point that we have here?
Around 24.
0?
Negative 24.
Negative 24. Again, use a point that you know for sure. Okay, that goes right through the y-axis. Now, you could have also used this point.
1.
Okay, that works pretty well. That point works pretty well as well. Okay, but we're going to choose to use the y-intercept. It doesn't matter, as long as it goes exactly through. So here, and please try not to estimate. So this, you would not want to use this point right here. Okay, you would not use that point right there. It would be an estimation, because it would be like 0.75 and negative 16. Use 0. 0 is a lot easier. So again, 0, negative 24 is your y-intercept. Plug in a 0 for x, plug in a negative 24 for y, and solve for x. Again, you're given this point here because this is your y-intercept right there. So please use that point as a coordinate. Mr. Malachek joke.
Chasing the ruler. Oh.
It's kind of funny. A little bit? It's funny. It's play on words.
What's the little word? Something.
Chasing the ruler.
Be quiet.
Now, notice, guys, I didn't actually plug in a 0. I just dropped off the x's. Because when you plug a 0 in for x, they just drop off. So you just have to simply write down what's there without the x. What's negative 2 cubed? What is it?
Negative 8.
Negative 8, thank you. Why is only one person answering that, guys? Come on. Negative 2 cubed is negative 8.
Negative 8 times 4.
So you get positive 3. The 1 doesn't matter. Again, the 1 makes no difference here. So your final answer is the same thing as the original equation, but with a 3 in for A. Okay, and notice I'm not writing all my factors out over and over again. I'm simply writing them as a group like that. Use your exponents to help you, please. Don't write all the factors out. You have to list all 5 factors there. But again, there are 1, 2, 3, 4, 5. Because we have a tangent with 2 and an inflection with 3 more. Again, this could have been a graph of x to the 7th. Or it could have been a graph of x to the 9th. But we don't know. So we can't make that assumption right away. We do know that there's at least 3 and at least 2, so it's got to be 5th. We didn't. We said that we could have used those instead of the y-intercept, but we chose not to use them. Okay? That was another possibility. Questions? All right, next one, matrix. So standard form now.
Matrix power.
Don't let this intimidate you, please. So, here's what I want you to think about. When we had a problem and we used standard form in the matrix, how many points did you need to solve a parabola? How many actually? 3. Do you remember why you needed 3 points?
Oh, you need to know.
Guys, you need to focus and listen. Stop talking now. Stop. We have 15 minutes. We have a lot to get through. Please stop. Again, we needed 3 points, as Ashley said, for a parabola, because a parabola is ax squared plus bx plus c. A, b, and c are unknown. Again, a parabola from last chapter. We are solving for a, we are solving for b, and we are solving for c. So we needed 3 points. Now, for this kind of a problem, again, we have 1, 2, 3, 4, 5 points.
So we 5.
This is where it gets tricky. You got to think, people. You needed 3 points and you got x squared, didn't you? So if you have 5 points, you're going to get x to the what?
X to the 4.
X to the 4th. Why is it 4th and not 5th?
Because there's that extra x on there.
Very good. The constant at the end. You said constant. The constant at the end. So here, you needed 3 points. You needed 3 points, which yielded an equation with a degree of 2. So if you have 5 points, it can yield an equation x to the 4th. So let's write that right away. Write y equals a x to the 4th plus b x to the 3rd plus c x to the 2nd plus d x to the 1st plus e. Look how many variables there are now that we're solving for. A, b, c, d, e. There's 5 of them. How many points did we have? 5 points. Remember, when you solve simultaneous equations, if you have 5 variables you're looking for, you need 5 different scenarios or 5 different equations. So at this point in time, it's just a lot of arithmetic and busy work here. It's tedious. There's a lot of room for error, so you need to be very careful. So here you need to simply plug in the first point, write an equation. Plug in the second point, write an equation. You're going to have to write 5 equations, because then you have to write a matrix with 5 rows and 6 columns. It's going to be 5 by 6 here. Okay, that's why this is not difficult, but there's a lot of work that goes into it.
Yeah,
Let's do the first one together.
Yeah, rearrange it differently.
Let's do the first one together.
Yeah, rearrange it.
Why would you rearrange it?
Because it's going to be in the matrix, and you have to do the reference thing.
Absolutely right. Everybody listen to what he said. Rearrange it. Put your y over here before you plug in. That's exactly the next step we're going to go through. Good job. Because the matrix is in order of all your A, B, C, D, E, and then all your constants are on this side over here. Okay? Again, your answer is always over here. So if you want to put equals y over there now, it might help. So you're going to plug in a -3 for all of these x's here. And be careful when you square or cube or raise a negative to a 4th power, you have to care about your signs here. So -3, I'm just simply going to write it as a substitution first, and then we'll explain what each one is. If you know already, just go on your own, please. But when you plug in the -3 for these, now this is a clear example of a time that you're not going to want to solve this by hand. Remember how I said in real life, you're never going to really solve a matrix by hand. Use the calculator. You don't want to do that. You don't want to do elimination method with 5 variables and a number like 103. Okay. So this is exactly how. This is exactly how they fit curves if you're given data. So if you want to be a statistician, or if you want to be someone that works in statistics and looks at data analysis and finds trends and stock market trends when they fit data to smooth curves, this is what they're doing. They pick certain points along the way and try and fit a curve to it so they can estimate or predict the future. Okay? So here, looking at this equation, we have to do this for every single one. Okay? We have to do this for the second line, for the third line, for the fourth line, for all of these lines here. Okay, so you're literally going to have to write them all out, and then you're going to have to raise them all the corresponding powers. If you can do it all in one step, I encourage you to do that. And here's what I mean. Many of you already probably did this, I hope. What is 3 to the 4th?
81.
And it's negative.
Right.
It's negative, but it's to the 4th. What goes on there? Good. And when you raise something to an even exponent, even if it's negative, it becomes positive. Just like when you square negative 3, isn't this positive 9 really? This is really 9c there. Again, that's really 9c because it's a negative squared. A negative to the 4th is also positive. So 81a, this is going to be minus 27b plus 9c minus 3d plus e equals 103. Check out those numbers, make sure they make sense to you. Negative 3 cubed. Negative 3 cubed is negative 27. Negative 3 squared is positive 9. Negative 3 by itself is just the negative 3d there. The e gets carried down. What is the e always going to have a coefficient of?
1.
E will always have a 1 there, because there's no x in front of it. There's always going to be 1 the whole way down. Now, I do not want you guys to write out the blue line every time. What you should really do is be able to plug this in and get the green line right away. So plugging in the second one, the negative 1 here. So plugging in a negative 1 in all of these spots, in those 4 spots now. Okay? Okay? And you notice, no matter what you do to 1, guys, it still remains 1. 1 squared is 1. 1 to the 3rd is 1. But the negative sign you have to account for still. Again, the same negative trend applies here. The rest of the numbers will be a lot easier. How come? They're all positive x values. Again, these 3 values are all positive x's. So when you plug those in, you're going to have all positives the whole way. So this next line.
Can we just write them as A, B, C, D?
Yes, absolutely, guys. You don't need the ones. You don't need the ones. You definitely do not need the ones in front of everything. I'm just putting there as placeholders. Then I plug in the 2's. What's 2 to the 4th? 16. So this is going to be 16a plus 8b plus 4c
Oh, go in front of them.
plus 2d plus e equals 18. Again, notice these are just powers of 2, aren't they? 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st. What about the 4? Anybody got the 4 for me?
256.
Good. 4 to the 4th is 256.
Oh.
Good. 4 to the 3rd is 64.
16.
What is a square? Is that how it is?
So here's your matrix, everybody. Again,
Hey, Mr. Howard.
try this on your own now.
Is it 5 or 6, right?
1, 2, 3, 4, 5, 6.
Here's your hint in case you forgot how to do that. Please go on your calculator, figure this one out, please. If you don't know, talk to a neighbor.
So that would like,
Yes.
switch to
446 to the 4th?
no, 446, like, put the 4 as the Y.
I know, but I'm saying that you'd have to do 446 to the 4th.
I know, that'd be funny, though.
But it wouldn't work.
It wouldn't?
No, these points are specific. I didn't make those points up randomly. These points specifically work for this function. Yeah, that's the thing.
The E is 0.
So we throw it off completely.
1.
That would thank you.
Good question, Jason. These are all ones. These are all ones.
Oh, gosh.
Only if something is missing, only if it's missing, okay? Only if it's missing do you see a 0.
76.
And again, you're getting A, B, C, D, and E. So you should have 5 answers
Are they supposed to be decimal?
in that order. They actually turn out to be whole numbers. So if you don't have whole numbers, you might want to go back and fix something.
I got the answer. Oh. I got the answer.
Tell me right now, hold on.
He's like, whoa.
No. Oh man.
I'm confused on something.
Not giving you the answer, Leon, you do it yourself.
Wait, what the hell? Why do I have? He says all numbers.
Your answers be whole numbers, so if you didn't get it right, go in and fix. Go take a look. If you have all decimals, you made a mistake. Go back into your matrix, look to see if you typed everything correctly. Again, make sure it's 5 by 6, not 6 by 5.
Is this right, Mr. House?
I'm going to put up what it will look like right
No,
now.
not yet, not yet. Come on, Leon.
Alright, so you got another like 2 minutes till I get to it.
No, don't put the answer up. I'm trying to check it. Just don't look.
That's fine, Jay.
Huh?
Just check it up here when you're ready. Don't look up until you're ready.
I'm right.
Okay, check your answers, please. Take a look up here and check your answers at some point. I have another 1 there. That's annoying. That is weird. Ah, there it is. Okay, I don't know what's going on with the screen, guys. Some lines are getting cut off, but again, that's what you want for your matrix to see what the reduction looks like.
Yeah.
What this is doing is
There's all one later.
the opposite of 3 squared. So the calculator
Yes, I got it.
is 9, and it takes out 9. That's correct, but that's what it's not. Make sure you want to miss that video, so talk about that. Exactly what we're doing right there. That was in week 2. If you did not get this and you need help still, come after school, please. Again, if you did not get this solution and you still need help, make sure you come after school. This is a -5 here. I know it's getting cut off for some reason.
Yeah,
Okay.
it's Ralph with the 2 R, right? It's Ralph with the
R-R-E-F, 2 R's. If you use the regular R, it might not work. Ralph?
Also, we're not.
Last one.
We're gonna have to write it out. Once you're done, enter it in. We have to write it out.
Yes, guys, once you're done, write out the answer, please. I just showed you the answer a second ago, John. Once you're done, this is what you need to write right here. Where's the x cubed, guys? Good. See this 0 here for b? That was b value. B was in front of x cubed in the beginning. So b dropped off. There's no x cubed because of the 0. So this is telling us that b equals 0. Everything else was carried out. In the last problem, you're going to have 2 minutes to solve this on your own. Try your best here. Quickly, what degree will this polynomial be? X to what power?
Fourth. Third.
Third, again. Here's how you can tell, first of all. Take a look, everybody. It goes up like this. So it's got to be odd. Remember, even either opens down or opens up, so it's immediately odd. It's odd positive, I can tell you that already, because it looks like this. Now you see you have 4 points there? When you have 4 points, it's going to tell you that at best all you can approximate is x cubed. If you had like 6 points, then you can make it x to the 5th if you wanted to. But 4 points tells me that I go like this. Again, 4 points, and I'll have 4 variables, A, B, C, and D. Plug in the 4 points in, get your 4 equations, get your matrix, and solve. Okay, all the answers for this are all online. So the first one you'll see on that line, and the second one is also on there at the bottom. Okay, on the last page. Please make sure you try this yourself now and then check it tonight. And I have homework for you tonight.
That's the best Valentine's Day present ever.
It's the best gift
I
ever.
got my pencil sharpener
No,
back.
you're not.
Give me your chocolate.
The papers are scented with rose scent. Oh.
Just smells it too.
I mean, should I have, like, pink paper maybe next time?
Yeah,
Give us chocolate.
Give me one.
He's wearing red.
We'd be wearing around the whole roll.
That's not even
Oh, yes, go there on. Guys, we're missing one copy. There's an extra somewhere. Who's got the extra? What row? That's extra?
Yeah.
Give that to Daniel.
What?
You need a copy of the homework. There's one short.